It was quite interesting, this being a CIO a group that's gathering together. In some organizations that I've worked with, there's a distinct difference between the CIO and the CDO, or the CIO and the Chief Analytics Officer. Some of them have the Chief Analytics Officer reporting to the CIO, and others they're reporting to finance, or they're their own part of the organization. So all in all, very interesting. But let me tell you a bit more about myself very quickly. As has been mentioned, I used to be the Chief Analytics Officer for Just Giving. For those of you who don't know, does anyone not know who Just Giving is? It might save me. I'm not going to judge your generosity if you don't put your hand up. Long and short, we're the largest Just Giving is the largest online social giving platform in the world. They have, it says 23 million users, but I think by now they have around 27 million users, operate in hundreds of countries, and have raised in excess of 4 billion for great causes out there. So just to give you a feel of the size of the organization. When I joined, we were 30 people, and we had all of those cultural challenges when we eventually got to 100 and so people. I've also written the book Cracking the Data Code, and pleased to say that got to Amazon #1 bestseller status in February this year. So that was an exciting moment for me. And also I'm a contributor to the book Big Data and Business Analytics. So the real reason I'm here to talk to you, as I said, is all about this AI machine learning space. How many organizations are actually doing stuff in that space, have invested in data science teams and so forth? Have any of your organizations done that? Okay, great. And are you all seeing value from it? Are you all seeing the corresponding value that data and analytics promises? The game-changing ones? Okay, there's a few nods the wrong way, perhaps. And that's a big challenge for a lot of organizations. Most of us are aiming, when we talk about analytics and data science, we tend to think of these three, right? So I think if you add Netflix in there, they're called the four horsemen of the internet, I've heard them being called. But you've got Amazon's recommendation engine, you've got Google's PageRank, and Facebook's EdgeRank. So all companies doing really fantastic work with data and analytics. The trouble I feel when using these as examples is it creates this feeling that to succeed with this, you kind of have to be in the US, perhaps in the West Coast, and have some sort of startup background, which excludes many organizations that I've spoken to today, right? So I like to think, before we start getting into the hows, let's talk about some other successes outside of those organizations. So has anyone heard of the Black Dog Institute? Yeah, so they're a great organization that have used analytics primarily with soldiers coming back from Afghanistan, soldiers coming back from war, who have a high propensity to suffer from depression or some sort of mental illness. And they use analytics to predict the likelihood of someone getting depressed, and also when they're likely to get depressed. So it's some really fascinating insights there. For example, from their research, you can see the distance that you move from your house is a really strong predictor of how likely you are to become depressed. More importantly, not only can it predict, but it can also prescribe. So you can intervene rather than wait for the condition to arrive. Catapult, anyone heard of Catapult? Great organization, and pretty much all the top sports teams in the US use Catapult, so they can predict when a player is likely to get injured. They can also prescribe the sort of training methodologies, how long you let them play for, and so forth. So really interesting use cases there. Anne Milgram in the middle there, she does a fantastic TED Talk, you should look at it. They use analytics to pretty much reduce crime. She was the Attorney General, I think, in the state of Connecticut. She does a fantastic talk on how they've used predictive analytics to help with sentencing, to improve the human biased approach that we tend to have, and used it to literally reduce crime that takes place in the streets. So of course you've got the police who are using it to understand how to deploy some of their forces, and you've got counterterrorism techniques. Interestingly, some of the techniques that were used for counterterrorism, we also used in the giving space, and I'll get into that a bit more later. Generosity, predicting world hunger, corruption. So there's lots of use cases outside of big tech, West Coast, America, right? I think that's just important for all of us to get onto that same page, that there is stuff that you can do with it. Now, sadly, most organizations, I think Gartner and Forrester will tell you, that invest in this stuff, most of you guys who've invested in this stuff, will fail to see a return on investment, right? Data scientists are not cheap. They're an expensive resource, but creating tangible value from this sort of stuff is really, really difficult. It's not impossible, it's extremely difficult. So I'll walk you through a story, because we were, at Just Giving, very much in that 75%. In fact, I've just seen a stat before I came in here where that number is even worse than that. I think it says 96% of organizations that claim to be doing stuff with AI will fail to see any sort of return in that. So the number is pretty large. So to illustrate some of the typical challenge you have with that, let's go through a story that, a true story that I went through. You have a marketing team, and they decide they want to predict a predictive model to predict churn, right? So to see if they can work out who's likely to leave their organization, or which consumers are likely to not come back, and how they can get them back and make another purchase, right? So the first thing that you do, you get a new idea, is you create a data science team, okay? And you go and find people who have a PhD, typically, is what most organizations tend to look for, a PhD, and then they can come in there and teach them or get them to do machine learning on their platform. Now this already has some concerns and some problems, because you know how long it takes to find a real data scientist. There's the unicorn that everybody talks about. We can see whether they exist or not, but it takes a while. It takes a while to find these resources, okay? Second thing that you encounter, so that's the first problem you encounter. So you've got your idea, you've already lost 2 months because you're hiring, okay? The second problem that you encounter is firstly your data. It's all over the place. And if you have a separate analytics team to IT probably has their own priorities, right? So analytics might not be at the very top of it in terms of getting that data cleaned up, or doing that great consulting exercise that we used to sell for 18 months, that one version of the truth, right? You know, it's a great 18-month project that never really ends and is very, very expensive. So you've got problems with the data, it's all over the place. You've got problems with the marketing team, the way they were coding the data, so it was coded differently. There's lots of gaps, so it's just not clean. So not only is it everywhere, it's also not clean. And then, so that's one problem you have. You start trying to clean that, and you lose another 3 months. So you've now lost 6 months of your project before you've even started anything with data science. So let's say you clean that up, and you start building these algorithms. You then see that actually it's no more successful than a coin toss, right? 50% is all it can produce. It's all it can predict. So it's not much better than you guys making the decisions yourselves if you were doing guesswork. This happens all the time. This is a real thing, and that's purely because there was no signal in that data that you had. See, what a lot of people forget is that machine learning and artificial intelligence, whatever you do in that space, is a journey of exploration. Even if someone else has done that before, it is a complete journey of exploration, because for your organization, there may or may not be any signal in your data, right? So in this case, there wasn't any signal for us, and we're sitting there saying, okay, we've lost another 3 months, 9 months into it. Business is now starting to look at us a bit funny. It's an expensive team. There's 8 of us, you know, average salary, what, 60, 70, PhDs, amazing, you know, brains in the room, and we're still not getting value. So what you do is you say, okay, let's go back to the domain experts and see if they know a little bit more about what additional data we can collect. Takes time to build the systems for them to start collecting some more data, but domain experts are absolutely essential to this process, because as humans, they're still able to know something a little bit more than the machine can. After all, the machine can only learn from a training set of data, right? So just giving, for example, we were using this to try and predict what images should you put on your fundraising page in order to maximize how much you'd raise. And the machine kept saying, put a bicycle, picture of a bicycle, put a picture of a bicycle. Now, from a machine perspective, it wasn't wrong. But actually the reason why, if you knew the domain very well, was because most people who decided to cycle for charity tended to raise quite a bit of money, right? They tended to be middle-aged men who were very competitive and decided to take on cycling. I think there's some in the room, right? Who's not done that in the room, right? So, and so again, that's where the human intuition could trump that, because we didn't have that data to train the machine, right? So you needed the domain experts to be able to tell you that. Your data scientists by themselves would not have been able to ascertain that. They can use the machine, they can pull out information from that and use the predictions, but you still need those domain experts. So you've lost more time, okay? But finally you get all of this sorted. Your domain experts give you the data, IT have helped you out for a little bit. You go and you build your algorithm, and now you're predicting 96% better. This is a true story. Okay, so we had an algorithm that was 96 better than any of the decisions we've ever made in terms of who to email to try and get them to come back, right? It was able to pick people from our database pretty much right most of the time, and getting them to come back and make another donation, right? So in some of your cases, it'd be getting them to come back and make another purchase. It's fantastic. You go out with the marketing team and you have a party. Everybody gets really excited. We're now going to change the world. Come back the next day and they go back to using their Excel spreadsheets, right? Okay, standard problem. We as humans like simplicity, ubiquity, like to stick with what we know, right? And data scientists, machine learners probably aren't the best at selling a solution, right? We can write some fantastic algorithms, but in terms of packaging it so that it's useful for everybody in the room, everyone in the business, it becomes very difficult. People identify with some of these issues so far? Yeah? Okay, great. So just exploring those issues again, you get to that stage where the business is now saying, okay, we've spent a lot of money on this. You had a 3-month project that's now taken more than 12 months. You weren't even able to get this thing to work. When you eventually got it to work, no one's using it. So you get this sort of view within the business that this mythical black box is not really producing what you're expecting it to produce. You got expensive people on there, and they're probably going to be poached by Facebook. True story, all right? They've been poached by Facebook. So you've lost some talent. You've lost some guys who've built in finally some domain knowledge around your data, around how your business works, and they've gone. Business loses faith in it. But interestingly, most of the organizations that I work with would still keep as much of the team as they can because their competitors have, right? And the last thing they wanted to do is to be left behind because their competitors found a way to get it to work and you didn't, okay? So overall, those problems, let's summarize them into the five key problems. You've got problems with prioritization, your data's all over the place, you've got algorithms that don't produce what you're expecting, you've got a lack of domain knowledge, and then you've got to try and change behavior, change cultures. I think we were talking about that this morning. You know, there's just a way of doing things. Imagine going to the real story. I go to the marketing team and I said, look at this algorithm that does so much better than the way we're working at the moment. And the response you get is, I've been doing this for 25 years, right? I know how it works, right? And so they stick with their traditional way of doing things. And so the business start asking questions. So, as I said, the one thing that cannot solve this is getting a better data scientist, right? The biggest mistake most organizations get is they take the combination of saying, we get really, really good data scientists and an idea, and we solve the problem. Actually, it's not a technical issue at all. And that's why you still have most of the organizations still failing, because they believe it is a technical issue. So what are the ingredients that you need to get it to work, and how did I find them? So basically, I stalked everyone that I could find on LinkedIn through Facebook, or that was on Facebook, that was in Netflix, that was in Spotify. I genuinely stalked them until they could meet me, right? Because also my job was potentially on the line, at least that's what I thought. And I met with them, and what was really interesting is I found a very distinct pattern between all of these organizations. There was something that was similar to all of them that was different to the rest of us, or different at least to the idea of a data science team and an idea is all you needed. Something very, very different, okay? And we took those techniques, basically cleaned them up, applied them at JustGiving, and we were able to build this. This is a machine's view of the whole world of giving, okay? And what the machine was able to do, we were able to build neural networks, random forests. Again, I'm using language that most data scientists use. Interesting fact, I think we do that for job preservation, right? There is no real reason why we should be using some of those Greek symbols or some of these technical terms when we should be speaking English. It's another big part of the problem, actually. So I've had to move away from that. But I think this slide was to impress some data scientists when I've been presenting before. But essentially, we got to the stage where we could predict exactly how much you were likely to donate the moment you got onto the platform. So the moment you arrive at justgiving.com, we know how much you're willing to give, right? But even more importantly, when I talked about that interplay between predictive analytics and behavioral economics, we knew how much we could get you to give, and you wouldn't even notice. So as a small anecdote, if it was raining and you were in Scotland and you were looking at a JustGiving page on your mobile, you would press donate to whatever number was in the prompt, even if it was £100, right? Well, certain people, and we knew exactly who. This obviously forced us, I'm going down a different route, actually, a tangent, but this meant that we had to create some sort of ethics committee within JustGiving, just for us to be able to manage what we could or couldn't do, because it was really interesting with this sort of stuff. You can manipulate people, and that boundary is quite an important one to address. But yes, we could predict exactly how much you could donate. We could also predict, if you decided to fundraise, what page were you going to create? Were you going to run a marathon? Were you going to sit in a bathtub full of beans, or were you going to, cycle, as some of the guys here? We also could predict what targets you should put on your fundraising page, and we knew the targets that would make you come back again. So, for example, if you raised more than £75, you doubled your chances of fundraising again. If you raised too much for some people, it was too much of a challenge, and you got exhausted, you got fatigued. There was no chance that you would come back. So we knew what targets we could give, we knew what content you'd be interested in, what other giving things you might be willing to give, and at what time. Because giving spreads through some of our networks and it changes through some of our networks. So the last thing we checked was all of our networks. We knew the strength of connection between people, the context of connection, and we could understand how information flows through each of those connections, right? So how generosity flows through each of those connections. So basically what I'm saying is we took those patterns, applied them at Just Giving, and we got them to work. Now bear in mind, we had a really strong data science team that could do amazing stuff. And with all of these things that I showed you just now, they were just sitting on the shelf because the business wouldn't use them. The product team wouldn't apply them, the marketing team wouldn't use them because, you know, it does scare people. I think someone was saying this morning or the talk before, that we've got to try and change the conversation around AI and machine learning, that it's here to enable us, empower us, remove the robot from the human, if you like, and allow us to do things like improvise, create, strategize, and let the machine do the mundane, sort of repetitive things that are happening each time. So, the 5 ingredients that we saw very clearly. The first one was each of those organizations had a leadership team that understood 3 things. They understood exactly what machine learning and AI was. Who here has a leadership team that can tell you the difference between those 2 things, right? They had a leadership team that understood what those were. Secondly, they knew the cultural aspects that had to change within the organization. And the third thing is they knew exactly what their role was in making machine learning and artificial intelligence work. It'd be really interesting if you think about the leaders within your organization. Do they know the role that they are supposed to play in getting this stuff to work, right? It was very, very different in those organizations. I think Facebook, when I spent some time with them, were talking about the fact that they had a 2-week course, which they put everyone on, regardless of seniority or how junior you were, a 2-week course for everybody within the organization to understand how to work with data. And the first week was not technical at all. The first week was purely dedicated on how do you even ask data questions, which is something we take for granted, but it's actually a very difficult thing to come up with. How do you ask data the right questions that are relevant and add value to your business? So those organizations were very different. The next thing that we saw is all of them, in fact, I'll say most of them, because Netflix didn't have this at the time, had some sort of data leader, so a chief data officer or a chief analytics officer. Now, this isn't just somebody who's in charge of that exercise. Interestingly, the role for most of these guys within those organizations was upwards. It was to continuously educate the leadership team, right? Because everyone knows here, you can't have one training session and then suddenly become an expert. So the leaders constantly needed to be reminded on those 3 things that I talked about, you know, and particularly the role that they play in getting data and analytics and machine learning to work for their organization. So it was less management of the analyst, but of course there was a big part of that. The other thing is, analysts by nature or data scientists, we prefer over-sophistication. A regression model or a genetic algorithm, you know which one we're more likely to choose, right? And most of us should also know that a more sophisticated algorithm will only give you a single-digit uplift in the metric that you're trying to move. Whereas if you add more data and the variety of data, so I gave you the example, the fact that it was raining in Scotland, will give you a double-digit uplift, right? Irrespective of the sophistication of that algorithm. So there should be more focus on generating more data rather than having a really complicated algorithm, which is difficult to manage when you're working with data scientists who their bread and butter is to create complicated things. So that was the second one. The third one is they all had a portfolio approach. So when we talked earlier, I talked about the one idea that we had. And when you go down the route of a single idea to begin with, the first thing you encounter, like we said, is problems with the data, which means your team is twiddling thumbs until you get the data sorted. But with a portfolio approach, you're suddenly in this position where you can be a bit more agile, as we call it, right? Because you have different things that you can address at a different time. It also shows similarities. It shows algorithms that can work across multiple ideas rather than one. But all of them had like a whole pipeline of activities that they could be working with rather than a single idea. The second thing is none of them had a unicorn. Out of all of the organizations, you would expect those organizations to have a unicorn. None of them had it. They had different roles. They had a machine learner who was purely there to write algorithms, not to write enterprise-grade code, and not to be a data engineer, because that's just expensive and really difficult to do. And getting someone with a PhD because they can write a regression formula doesn't mean that they'll know how to manipulate data. In fact, most of the time, they have no idea how to manipulate data, and you need data engineers. So they had different roles. They had a data engineer, they had a machine learner, and they had what they called a machine learning engineer, who was essentially a developer who can write enterprise-grade code over an algorithm, right? And the machine learner was not tasked with making that algorithm production ready, right? Because that's all they were supposed to do, is make sure the algorithm worked. And they had another team, or another individual, if you like, that could make it production ready, so that however many millions of users, or even users internally, could actually use it. So 3 different ones. But they also had what we could call almost a humanist, a hybrid, if you like, between typically someone who comes from a management consultancy who can speak a little bit of the mathematical language. I think you call them business partners now as well, but can also communicate with the business. And the deployment of those people was really interesting, because they were not centralized. They were all native, so that they could feel the pain of the respective departments. But they still had a centralized department, so that they could at least remain efficient and stick to certain policies and rules. But they needed those guys to go native and really get a feel of the business needs and the business problems in order to come back to the rest of the team. And that was really quite useful in terms of getting buy-in. And I think lastly, they had a very, very different culture. We talked about culture here, but they had a data-driven culture, which is what we aspire to a lot of the times, and that's really, really hard to change. I was told by the chap that I met from Netflix that if you didn't conform to being more data-driven, you were out the business. It was that brutal. It wasn't a process of trying to change you or trying to improve you. If you didn't do it, you just weren't in there. They wanted people who were already that way inclined. Facebook, as I mentioned earlier, takes time to try to train people and get them up to that position. I think I'm running out of time, so I better rush. So those were the, sorry, do I have any more?
Yeah, you're okay.
Okay, so those were the, if you like, the 5 key things. I've put them all in my book. I took some time to write that after interviews with all those. I've got 5 copies here for first come, first serve, really, if anybody's interested. It is available on Amazon as well. Yeah, and I think one more thing, actually. So what I did after I left Just Giving, aside from writing the book, is then I went and set up an organization that tries to get this new perspective of AI into play, right? So working with organizations that have built their data teams, that are struggling to see value from them, or at least the execs that are struggling to see value from them, and it's rarely a technical issue, right? So the organization that I built, we do 3 things. We focus firstly on training the leadership team. We did this all came out of the work that I used to do at Just Giving. So I found when I was trying to train the leadership team, it wasn't as effective, because I'm an internal person. So what we did is we got an external prophet, if you like, told them what to do, and they came in and trained them, and it was far more effective than we've ever seen. So it was just something about someone from the outside delivering the same content. So that's one of the things that we do. The second thing is helping them discover those use cases so they can build that portfolio of AI opportunities, but more importantly, have a tangible link between everything that they build directly to whatever metric it is you're trying to move, whether it is revenue or number of users or anything like that, to build a really tangible link between them. And because this is a human and machine activity, what we do in our company, we really respect human beings, right? So we respect the mind and the way it works. So we use a technique that involves Lego to try and open up some of the executives' minds. It's great watching execs play with Lego. A lot of them come in, they're like, nah, don't do that. And then halfway through, they're like, look at my model, it's bigger than yours. But it's a great way to unlock neurons within the mind. I mean, when was the last time we were creative? I think the last time we were creative was when we were children, when we were playing. It's the time that those neurons suddenly turn off as we grow up for some reason. But using Lego really unlocks some of the way you look at your business. You look at your business as a system of decisions and people making those decisions. And suddenly all of the AI opportunities, the low-hanging fruit, just come out of that. And then delivery. When you're building those algorithms and you're putting them in front of users, a lot of the time what a data scientist or an engineer will build is just not friendly enough or usable enough, if you like, and it's not embedded within the existing processes of those teams that you're delivering it for. When you're trying to get them to change, we always found that it was difficult to try and get someone to go from an old process to a new process. So what we did was to try and embed it within the existing one, and using a lot of behavioral economics techniques to try and get the teams to now find this new habit, or almost replace an existing habit with some of the new things that we had put in place. And that's the end of my presentation. Thank you very much.